back to your favorite channel or beloved channel Chemistry with RK. So today in our lecture I have come up with a physical chemistry chapter called as Ionic Equilibrium, which belongs to 11th grade actually. And if we talk about the importance of this chapter in different competitive exams is huge, okay. So it's very important. So students should not skip this chapter if a student is preparing for any of the competitive exams. You know what and all is included in this chapter. Before going to that, please I request you to subscribe to my channel and don't forget to click on the bell icon to get the regular updates so that you can enjoy the classes, so that you can learn concepts, so that your upcoming competitive exams can go very happily. Okay, so yes, let me first tell you the weightage for this particular chapter in different competitive exams. Yes, ultimately we are going to get one question directly from my particular class, especially from this particular Ionic Equilibrium chapter. Okay, and then if we move to advanced, yes, you know we have certain choices, because you know in advance the question number will be less and the chapters we have in chemistry are more. But one thing I have been observing from past few years, what they are doing is they are trying to correlate this particular chapter with thermodynamics, with chemical equilibrium and electrochemistry, and then clubbing all these chapters they are preparing, they are trying to prepare a beautiful and superb question actually. Okay. And then if we move on to Neet, yes, we'll obviously get one question or more than one question is also possible, which are going to be straightforward, maximum up to NCERT level. So if you follow this particular video lecture of this chapter, so mostly I am going to make some 10 to 12 videos on this ionic equilibrium, because it is a very huge weightage containing chapter, and the chapter the content involved in this particular chapter is also very big. So you are going to get maximum all videos of this particular chapter soon. I'll upload regularly, so please do follow, please do watch the videos too, and separate out the notes. So from this video I'm going to give you one more extra facility, that you can able to download directly whatever PDF I'm just using to explain my video lecture, so that you can download directly by scanning that barcode into any of your electronic devices. Okay, so that you will be getting in the end of the discussion. Because after listening to the class, just by clicking that barcode, if you can download, then you can clearly understand clearly. Like what I mean to say is, separately no need to write down whatever I am telling. Okay, so after explaining everything, finally I'll be giving you a barcode, so that if you can scan completely, my particular notes will be downloaded into your electronic device. Okay, so yes, that is a facility. You can able to use it. Please, I request. So please watch the video and then download that particular PDF, so that it will be helpful to you. Yeah, coming to our today's video, that is I'm going to give you the introduction on this ionic equilibrium, and then we are going to discuss about certain acid base theories. We have Robert Boyle theory, Arrhenius theory, Bronsted-Lowry theory, and then Lewis acid base theory as well, right? Yes, okay. And then I'm going to involve at the same time, parallelly I'm going to give you some previous year questions. In every video I'm going to make sure I will be including this PYQ, so please make use of that. Yeah, without any delay, let us start our today's lecture, that is ionic equilibrium. Yes, and now first of all, if we just talk about a particular substance, okay, so let me just give you an introduction, just a quick introduction. Okay, so suppose let's say we have a beaker, let us take the same, yes, this is again a different beaker, separate beaker, and now in this I have taken just NaCl, that is our table salt. And now in the other beaker also I am going to take the same NaCl, that is common salt or table salt, but in this we are going to add some amount of water. Yes, we know this is not called as a solution, since we have only one component in the first beaker. Suppose it may just for time being I am just denoting this as A and then this is B. Okay, fine. And now in the first A beaker, we didn't take any thing else other than NaCl. That is only common salt or table salt we have. And now what I am doing is I am trying to put a electric wire in this particular salt, and then on the other end I am going to connect to this plug. Okay, I am just going to connect this to the electricity. And now after once we switch on this particular switch, by putting your finger into that particular beaker, what do you experience? Do you feel shock? Do you feel that electricity passing into your body? And then, okay, let us just wait for the answer. I hope you understood what I am talking about. And now doing the same thing into this other second beaker, and then switching on this particular switch, then now this has NaCl plus water, right? So which mean that it is now a solution, salt solution, where this NaCl is going to exist in the form of Na plus and Cl minus. Generally, in the presence of water, the electrolytes will dissociate to give us differently charged ions. They are cations and anions, we know, right? So in the similar way, do we expect the same in the first case? No. Here we have all NaCl crystals only. So which mean that Na plus and Cl minus ions will not be in free motion. But whereas in this second beaker, because of this water, this NaCl has split into Na plus and Cl minus, which have given us two differently charged ions. And now doing the same thing, if you try to put your finger into this beaker and then switching on that that switch, then what do you experience? Where do you feel that current passing into your body, in the first case or second case? Please comment your answers in the comment section. Okay, yes, either A beaker or B beaker. Among these two beakers, in which beaker you will feel that electricity passing into your body? So I am going to reveal the answer. So before listening to my answer, you please comment your answer in the comment section. Okay, yes, we are going to see this particular second beaker will experience. Yes, if you place your finger in the second beaker, you will obviously face that electricity passing into your body. Why it is like that? We have free ions in this, right? One of the very important reasons for conducting the electricity. There are three possibilities where we can expect the passage of electricity into any of the object, that is body, human body maybe. Okay, so what are the cases? Generally in solids we say that free electrons, right? Free electrons are responsible. And then within the solids we can also expect one more possibility, that is free holes, actually vacancies, right? Vacancies or voids we say. So that we will see in the solid state. Actually we have a separate chapter called as solid state, where we are going to discuss about the conduction of electricity into the solid materials in the form of voids. Actually voids are also responsible for the conduction. Free electrons are also responsible for the conduction. Yes, so what I just want to convey from these two experiments is the same substance, that is NaCl, is going to behave differently in different situations. Why it is acting as a bad conductor, why it is acting as a good conductor. Okay, hope you understood. Here there is no other supporting molecule to split into the corresponding ions, right? But whereas here we have the supporting molecule, that is water, which can able to split NaCl into Na plus and Cl minus. Hope you understood, right? So what I am trying to tell you is just to try to understand. Yes, every substance behaves differently in different conditions, right? Yes, and now the same table salt will behave as a bad conductor of electricity in solid state because of no free ions or no free electrons. Hope it is clear. But the same table salt, it behaves as a good conductor of electricity in aqueous state or solution state or molten state. Hope you understood. Yes, why? Because of the presence of free ions. Okay, free ions. Yes, we have free ions. And now, so what we can understand here is, so based upon their ability to conduct electricity in the solutions, Michael Faraday has classified substances into two types. What are they? Electrolytes and non-electrolytes. Okay, and now what is the perfect suitable definition for electrolytes? And now electrolytes are the chemical species or chemical substances which conducts electricity. Yes, The substances which conducts electricity in the solutions are called as electrolytes. Very important. Hope it is clear. And now, yeah, one of the very important examples are acids, bases and salts. Yes. So generally acids upon dissociation gives ions, right? Agar hamare paas HCl hai, you know, by undergoing dissociation it is going to give us H plus and Cl minus. Yes, ions mil raha hai to conduct kar sakta hai is in the solution state. So acids and then bases and then salts. Yes, basic and very beautiful examples. Okay, right. So all acids, bases and salts are going to behave as electrolytes. Okay, right. And then next let us move on to the next one, that is non-electrolytes. Yes, it is quite opposite to that electrolytes, which mean that the chemical substances which do not conduct electricity in the solution state. Very important, okay, right. And now examples, yes, the compounds which cannot be able to give us ions in the aqueous solution, they are going to generally behave as a non-electrolytes, okay. And now it comes in the sugar, you know, sucrose or glucose. Yes, we know. So glucose and sucrose, you know, all sugars generally, okay, they are non-electrolytes, very important. And then urea, yes, which is actually again a pure covalent compound, so we don't have any option to get free ions to conduct. So these are the compounds which are going to behave as non-electrolytes, okay. And now electrolytes are further classified into two types. Generally, yes, within electrolytes we have different types actually. So strong electrolytes and weak electrolytes. Now what comes into your mind when I say strong electrolytes, okay, and now which mean that the electrolytes which undergoes almost complete dissociation or ionization in water, very important. So strong electrolytes will undergo maximum dissolution, maximum dissociation, maximum ionization. Yes, all terms of same. Okay, yes, strong electrolytes are nothing but which can able to undergo 100% dissociation, what I mean to say. So keeping this point in mind, please, okay, I request you to remember this point. Strong electrolytes kisko bolenge? Yes, generally the compounds which can able to undergo 100% dissociation. Almost all the molecules will undergo dissociation. Okay, so very important. Yes, into this particular category, strong electrolytes, which compounds will come into this particular category, that is, okay. Strong electrolytes में strong acids आएगा, strong bases आएगा and all types of salts भी आएगा. So into strong electrolytes we are going to consider salts, okay. So NaCl, KCl, H2SO4, which is an acid, strong acid particularly, strong acid, HNO3, strong acid, strong base, okay. So let me just conclude, that is strong acids, strong bases and all salts will come into this strong electrolyte category, okay. Very important, okay. Then next let us move to, that is weak electrolytes. Yes, it is quite opposite to that, which mean that the electrolytes which cannot undergo 100% dissociation. So suppose let's say if you have taken 100 molecules of that particular whatever, you know, if it is a weak electrolyte, suppose let's say, let us take an example. Weak acids, weak bases will be generally considered as weak electrolytes, okay, right. You take just acetic acid, which is a weak electrolyte which cannot undergo 100% dissociation. Yes, that is what I mean to say. Okay, so CH3COH is a weak acid, right? So since it is weak, obviously it can't undergo 100% dissociation. Clear? Right. Hope you understood. So just to take the example. Okay, so if you consider this, this is CH3COOH, H2CO3, H3PO4. You know, all these are weak acids and weak bases. Okay, so don't worry, I am going to give you, the list of strong acids and strong bases in the coming classes. Okay, right. And now let us just continue. Yeah, moving into this next. So that is about the introduction. Very important. I have given you a lot of information. So IIT में और Neet में और different competitive exams में questions अभी हमारा introduction part से भी पूछा हुआ है. Please, very important. Don't neglect anything. अगर मेरा क्लास को 100% समझ के if you try to solve any of the previous JEE questions, yes, I can assure you maximum answering part for your different questions, okay. So please, keeping that point in mind, please don't try to skip the video. Please watch it continuously till the end with a lot of patience. And now from this video I have given you another benefit, that is, anyway you no need to write down everything. Okay, so last May you can scan the barcode and then you can get the printed notes. Okay, right. Yeah, next let's move into our main discussion, that is acid base theories. Okay, yes. So in this we have actually main importantly the four acid base theories we have. That is Robert Boyle's acid base theory, Arrhenius acid base theory, and then Bronsted-Lowry acid base theory, and then Lewis acid base theory. Okay, right. So just let us continue our discussion. So let me start with the first one, that is Robert Boyle. Okay, so according to the scientist Robert Boyle, how he has classified the terms acid and then the bases. Okay, so according to the scientist Robert Boyle, an acid is the chemical species which can able to convert a blue litmus to red litmus. Very important. Yes, BR, blue to red. Okay, so according to Robert Boyle, so an acid is the chemical species which can able to convert a blue litmus paper to red litmus paper. Very important. And then see, what I am going to do is I am just going to give you the only the points of acids, and then opposite to that will be the basis part. Okay, so that will be the easiest part to understand, to keep everything inside. Okay, right. So what I mean to say is, so according to Robert Boyle, an acid is a chemical species which can able to convert blue litmus to red litmus. Super. And then generally acids are sour to taste and then corrosive in nature. And acids conduct electricity in aqueous solution. Yes, just now a few minutes back I was discussing about the electrolytes, right? Yes, generally electrolytes do conduct electricity. Yes, very important. So according to Robert Boyle, acids are nothing but conducts electricity in aqueous solution. And then what about the neutralization? Very important. Acid neutralizes when reacts with base. Yes, that is what very important. Yes, we know that, right? So acid jab base ke saath react hoga, we get a neutral solution, right? And now quite opposite to this will be the base part, that is turns red litmus to blue litmus, red to blue, red to blue. Okay, quite opposite to the acid part. Okay, and now bitter to taste, it is sour to taste, it is bitter to taste, it is corrosive in nature. Generally they are non-corrosive, the bases are non-corrosive, but they are soapy to touch. And then yes, they are going to conduct electricities. Yes, when we talk about base, it could be strong or it could be weak, right? Particularly if we just think about that, strong acids can conduct up to maximum extent. Okay, that will come in the next coming lecture, don't worry. And now since here acid, it gets neutralizes with base, and now let us talk about base. Since it is base, it gets neutralized when it reacts with acid. Hope you understood. So this is a small information we can able to get from the Robert Boyle theory. And the next theory that we have is Arrhenius. Yes, Arrhenius theory, especially coming into the competitive exam side. Yes, the questions are started already. Please, my dear students, please try to understand the concepts carefully. Please, if you have any type of query, please don't feel hesitate to drop your query in the comment section. Okay, right. And now Arrhenius theory के बारे में बात करेंगे. And now according to Arrhenius theory, yes, these scientists, they have given their own opinions about acids and bases. Sir Robert Boyle ने बोला कुछ, okay, about acids, and then now Arrhenius theory, and then later even Bronsted-Lowry theory के बारे में भी वो Bronsted-Lowry जो scientist है, yes, they are also going to give their different opinions and their how their approach towards this acids and bases. Okay, you know, according to Arrhenius, an acid is a chemical species which gives H plus ions when it is dissolved or react with water, aqueous solution. Okay, right, as we know HCl, yes, very important. Let me just give you HCl है हमारे पास. Yes sir, when we react this with H2O, yes, we are going to get H3O plus. Generally we write H3O plus Cl minus, right? Yes, so these are the possibilities. Okay, so sir, according to Arrhenius, H plus ion need to be produced in the dissociation, right? Yes, this H3O plus को हम क्या लिख सकते हैं? H plus and then H2O. Yes, this is what we need to understand. So when an acid reacts with water, yes, it is going to give us H plus ion. So we need to call this HCl as an acid according to what? Arrhenius. Very important. चलो, likewise you just try to understand H2SO4 में भी हमको 2 H plus ions मिलेगा. Acids को how many H plus ions मिल रहा है dissociation में? ये term भी very important. We call that term as N factor. Okay, N factor. So if we skip considering this N factor, then we are going to get a different answer which will be there among your 4 options. So N factor has a greater importance, especially in physical chemistry. So what we need to do sir, उस n factor के बारे में समझने के लिए already I made a video on that, or otherwise in the coming just maybe in the next 4 to 5 videos I am going to make a video on that n factor also. Just what you need to do is you have to follow me, right? Very good. So just you need to do is you have to follow me, that's it. Yes. So just try to understand everything. Yes, book open karo and then problem solve karo. That's it. Okay, right? Thank you. And then yes, you can see the n factor or how many H plus ions we are going to get. One, एक H plus तो मिलेगा water के साथ, so acid. And then similarly 2 H plus ions मिलेगा, and then 1 H plus, and then per chloric acid, yes, it is going to give us 1. And now when it comes to acetic acid, even though we can see 4 hydrogens within the molecule, but only 1 hydrogen is going to come out. And then H2CO3 में भी 2 आएगा बाहर, and then HCN 1 आएगा, HClO3 1 आएगा, 1 आएगा, 1 आएगा. Yes. And now all these are acids according to Arrhenius theory. Clear? Right. Hope you understood. Right. And then next let us just go to base. Base के बारे में, right, it is quite opposite again. The chemical species which gives OH minus ions when it is dissociated or when it is taken in the water. Suppose let's say we have NaOH, and if you are taking this in water, then what we are going to get is Na plus तो मिलेगा, and then इसके साथ OH minus भी मिलेगा. Yes, so that is what according to Arrhenius theory, a base is a chemical species which gives OH minus in the aqueous solution. Very important. NaOH तो देगा 1 OH minus, 1 OH minus, 1 OH minus, 1 OH minus. Magnesium hydroxide में 2 OH minus, calcium hydroxide 2 OH minus, 2 OH minus, ammonium hydroxide 1 OH minus, aluminium hydroxide 3 OH minus, ferric hydroxide 3 OH minus, zinc hydroxide 2 OH minus. Yes, let us not worry about how many बाद में देखेंगे. Yes, I'll teach you in the n factors and all. Okay, right. And now as of the information we have here, we can understand that acids तो H plus देगा water में, bases तो OH minus देगा. Okay, right. And now just going back, so this is the common and basic general equation. So this is also I have given here. So अगर हमारे पास ये 6 कुछ एसिड है तो उसको डिसोसिएशन में H plus और A minus तो मिलेगा, right? So if it is a weak, if it is a strong one, suppose let's say if this acid we are taking here is strong, then we don't see this double-headed arrow mark. So strong acids can able to undergo 100% dissociation, which mean that reverse आने का choices नहीं है. So we have to show that with single-headed arrow mark, which is not a reversible reaction, which is only a forward reaction, which will take place only in a forward reaction. So if it is a weak, suppose, as we know that weak electrolytes, weak acids कैसे behave करेगा? So generally it won't undergo 100% dissociation, उसका 100% dissociation नहीं होगा. So obviously we will have some molecules of undissociated HA molecules within the solution. Don't forget this point. Beautiful chemistry. Chemistry has a beautiful wide way of understanding. Okay, so very important. अगर weak acid है तो weak base है, suppose let's say, then they are not going to undergo 100% dissociation, which means that our solution में और undissociated initial जो molecule free है वो होगा. Very important. Okay, right. And now if it is a yes sir, if you take HCl, then we will have H plus and Cl minus, and then H2SO4. Yes, we are going to have their dissociation. So as I told you a few minutes back, their dissociations I have shown it here. You just try to understand. And then next, according to this Arrhenius theory, what is the definition he has given for neutralization? So according to Arrhenius, what is that he has defined about neutralization? So according to him, the neutralization is nothing but formation of water from acids and bases. Yes, generally we know that acid जब base के साथ react होगा, then we are going to get water plus the corresponding salt also. So that is what the neutralization according to Arrhenius. Okay, this reaction involves the reaction between H plus ion is involved from the acid, and then OH minus ion is going to involve from the base. So that we have to take out as water, and then the acid में जो negative part है, very important. Yes, you please try to understand. So yes, let me take acid, and then let us take base, and now we are going to get salt plus anyway water is also going to form. Yes, very good. And now acid may generally, just now we have taken an example, that is HA is an acid, and then BOH is a base, then what happens according to Arrhenius? Acid से H plus, base से OH minus, दोनों मिलके हमको वाटर के जैसे जाएगा. And now what about the remaining part? Sir, इधर A minus होगा, इधर B plus होगा. So A minus B plus दोनों मिलके we are going to get A B type of salt. Very important. These are all very lower level grade concepts, but very important. Most of the students, they won't understand. So just for that purpose, I am giving you some more deeper explanation. So just try to understand. अगर समझो हमारे पास HCl है और हमारे पास NaOH है. बेसिक एंड ब्यूटीफुल एग्जाम्पल. नाउ क्या करना है? एसिड से H प्लस को, बेस से OH माइनस को, दोनों मिलके पानी निकाल दो. And now what about the rest of the part? Na plus है, Cl minus है. Oh, beautifully we can able to get NaCl. Hope you understood. Right. And then next let me just take some other example here. How to do that? चलो everyone try to do this. सर मेरे पास H2SO4 है और मेरे पास NH4OH है. Yes. And now what we need to do? So the funda you have to follow here is acid से H plus, base से OH minus, पानी के जैसे. Now acid में minus part, that is SO4 minus 2, and then base में positive part, that is NH4 plus. Since we have two hydrogens here and then two OH minus need to be there, so that we are going to get 2 moles of water. And now sir हमारे पास नेगेटिव आयन SO4 minus 2 है, पॉजिटिव आयन NH4 plus है. So NH4 plus and then SO4 minus 2. So just you try to crisscross this, you are going to get what you are going to get. The salt we are going to get is NH4 taken twice, SO4. Super. Simple salt formations. Okay, right. So likewise, I have given a lot of examples here. So you please try to take the help of these and then try to understand. We have sulfuric acid and aluminium hydroxide. Then we are going to get aluminium sulfate, the negative part from the acid, positive part from the base. Yes, they are going to crisscross and then they are going to give us salt. Okay, and then next we are having these things also. Okay. Okay, and then next let us just continue. That is we have strengths, the relative strengths of acids and bases, how to define. And from this part we can expect so many questions. Our competitive exams questions are already started, as I told you. Please you try to understand. So the relative strength of acids and bases ka meaning kya hai? That is the strength is nothing but the extent to which अगर हमारे पास acid है, अगर हमारे पास base है, so up to what extent this acid is going to show its acidic character, up to what extent this base is going to show its basic character, that is what we are going to learn in this particular relative strengths of acids and bases. Strength can be identified or explained based upon the simple term called as a degree of dissociation. Very important. Degree of dissociation, very important. Okay, yes. And now what exactly is this degree of dissociation? Chalo, let us try to understand this a bit deeper. Okay, so let us just take, so actually alpha, that is degree of dissociation, is defined as the number of molecules ionized or dissociated by total number of molecules. Very important beta, you should not skip this. Okay, so in case agar question mein degree of dissociation ka percentage पूछ रहा है, suppose let's say they are asking the degree of dissociation percentage, what we need to do? Alpha percent is equals to alpha into 100, that's it, right? Yes, this is also a simple thing which we need to know. So before going to this, let us try to understand this alpha, that is the number of molecules ionized by total number of molecules. So just for time being, let me just take, suppose let's say I have a beaker, and in this I have taken 100 molecules of HA. Suppose let's say I have taken 100 molecules of HA or BOH, like base can also be taken, there is no issue in that. Suppose let's say I have taken 100 molecules of acid, and now I am mentioning you, if it is a strong acid, then what is the possibility? What is the case? Come on, I told you, I explained you this. Yes, I am expecting your answers in the comment section. Okay, sir, if we are taking a strong acid and then expecting about its alpha, then what is the possibility? Okay, right. Sir, if it is a strong electrolyte, a strong acid, a strong base, it could be an salt also, then what is the possibility? Sir, since they are strong acid, strong base and salt, they are going to undergo 100% dissociation. अगर हम 100 molecules लिया तो 100 को 100% dissociate होगा. So then what about the alpha value? Sir, 100 by 100, yes, it is going to give us 1. And my question is, can we have alpha more than 1? Never ever. There is a dialogue in Telugu Mahesh Babu movie, never before ever after. So yes, alpha is also like that. Okay, so that is alpha is not going to go beyond 1, because if you have taken 100 molecules, उसमें से 200 molecules कैसा dissociate होगा? 100 तो लिया. This is not a ghost story, right? This is a real story. Okay, so obviously 100 में से 100 maximum dissociate हो सकता है. So 100 by 100 we are going to get alpha is equals to 1. Now what we can conclude is, sir, beautifully we can write down alpha is equals to 1 for strong electrolytes. Beautiful. Okay, alpha is going to be 1 for strong electrolytes. Very good. Sir, अगर समझो weak electrolytes लिया, so if you have taken weak electrolytes, and now how to define that? Suppose let's say weak electrolyte है, what is the main thing you have to consider here? It undergoes partial dissociation. Partial dissociation. We don't know out of 100 how many are dissociated. Let us just imagine उसमें से 50 ही dissociate हुआ, divided by कितना है? 100 लिया. So obviously it is going to be 1 by 2, it is going to be 0.5, which is nothing but alpha is going to be less than 1. Yes, alpha always becomes less than 1 for what beta? Weak electrolytes. Beautiful. ये सारे चीज हमारा notes में PDF में होगा, don't worry. Yes. Okay, so very important. Just now let us go back to this. Yes, I have given everything here. So that is for strong electrolytes, alpha is equals to 1, which means that 100% dissociation. And then for weak electrolyte, alpha less than 1, which means that partial dissociation. Okay, 100 on 100 to dissociate nahi hoga. Right. So let us talk about the strong acids. Okay, and now so strong acids ko kaise define karna hai? So if a chemical species is undergoing maximum 100% dissociation, right? That's what we have discussed, right? Yes, the substances which ionizes completely, very important. Yes. Okay, which ionizes completely, which undergoes 100% dissociation, are going to called as acids, strong acids particularly. Okay, and now actually this particular definition won't suit the best. Okay, so yeah, just I have given the strong acids list here, just you can take the help of them. And then next, अगर हमारे पास weak acid है, weak acid, right, weak acid है. Suppose let's say we have a weak acid. So we know very well weak acids है तो partial dissociate होगा, less than 100% dissociation. So that's what I have given them, the substances which ionizes partially. Okay, the chemical species which undergoes less than 100% dissociation, which mean that, as I told you already, yes, हमारे solution में वो जो ions मिलेगा वो भी होगा. Yes, we are going to have H plus and A minus also. In addition to these, we are going to have undissociated HA molecules also. Because they are undergoing partial, we will have still some undissociated molecules. And now we know very well equilibrium constant. अगर उस weak acid को हम equilibrium constant को define करना है तो कैसे define करना है? Yes, if it is, suppose let's say HA gives H plus and A minus, so Ka, which is nothing but acid dissociation constant. What is Ka? Acid dissociation constant. It is going to be, that is, we know very well that how do we write equilibrium constant? Ka is equals to the product of concentrations of products, which is nothing but H plus है हमारा और A minus भी है, and then divided by, that is the reactants concentration or active mass. Yeah, which means that here the equilibrium constant is directly proportional to the number of H plus ions, we can say, or the concentration of H plus ions, we say, right? Yes, right. We can just deduce a particular relation here. The Ka is going to be, directly proportional to number of H plus ions, or maybe we can also just write down that is the concentration of H plus ion, very important. So how this particular relation is going to help us, okay, so that we will see. So just let us try to understand. Yes, so where Ka is nothing but the acid dissociation constant. Yes sir, suppose let's say, yes, I have given an example here. Suppose let's say I am talking about the dilution. So dilute करने से alpha value क्या होगा, that is very important. Dilute करने से number of H plus ions को क्या होगा, तो Ka क्या होगा, acidic nature को क्या होगा. So let us just try to understand beautifully within 1 minute. Okay, so that is, suppose let's say यही example ले लेते. Okay, and now we have 100 molecules actually, out of which only 50 got dissociated by the addition of some amount of water. हम जो water quantity add किया उससे only 50 got dissociated, suppose. Okay, so the quantity of water we have added is not sufficient enough to dissociate all of them. Okay, so obviously उधर alpha का value क्या होगा, 0.5 होगा, already I have taken. And now what you do is you just add some more amount of water. What happens here? And now अभी हमारे solution में जो undissociated HA molecules है 50 है, उसमें से और कुछ molecules भी dissociate होने का tendency होगा 100%, right? So now what happens? So due to the addition of water, which means that we are diluting, right? So since we are diluting, what happens to the alpha value? Sir, first case में 50 dissociate हो गया, अभी और addition of water करने से और 25 होगा. Suppose let's say we are thinking that 25 more got dissociated. And now what happens? 75 by 100. Yes, 75 got dissociated, and then total we have 100. And now the alpha value is going to increase, right? Yes, it is going to increase. So what we can conclude is, sir, dilute करने से हमारा number of H plus ions भी बढ़ेगा. Okay, dilution करने से H plus ions बढ़ेगा और अल्फा वैल्यू बढ़ेगा. H plus ions का नंबर बढ़ रहा है तो Ka भी बढ़ेगा. Yes, very important. And then acidic strength भी increase होगा. Very important. Don't try to remember the things, please. केमिस्ट्री में ऐसा कुछ चीज़ नहीं है विदाउट रीज़न डायरेक्टली अंदर लगाने का कोशिश नहीं करना है, प्लीज़. Okay, very important. Yes, everything has a reason actually. So if you try to understand, so I'm just concluding the things. Sir, dilute करने से dissociation tendency increase होगा, तो obviously H plus ions आने का tendency भी increase होगा. So H plus ions increase हो रहे तो Ka increase होगा और alpha value भी increase होगा. And now H plus ions increase हो रहा है बोले तो obviously it is acidic strength भी increase होगा. Okay, right, very important. So this particular relation is very important in our physical chemistry part. Sir, this particular box, I am going to take the help of this box even in the organic chemistry classes also. In the coming days, I will be uploading organic chemistry classes also. Yes, I am going to take the help of this particular box. So that is, Ka is directly proportional to acidic strength, and then it is inversely proportional to pKa. Okay, so which is nothing but minus log of Ka. Actually that I will discuss in the coming videos. Okay, right. And now when we have taken, or if we have two different acids है और उन लोग का acid dissociation constants and then alpha values differ, suppose let's say. So for just for time being, I have considered acid 1. Okay, so I have considered acid 1 को alpha value alpha 1 लिया, and then acid dissociation constant Ka1 लिया, and then for other acid I have taken alpha 2 and Ka2. And now if we want to define that acid dissociation constants and alpha value को relate करने का, so that term is nothing but relative strength. Okay, so that is nothing but relative strength. Yes, since we are talking about acids, so we call it as relative strength of acids, which is going to write it as alpha 1 by alpha 2 is going to be equal to under root of Ka1 by Ka2. Yes, by taking the help of this particular relation, we are going to get the relative strengths. Yes, I have taken several examples also, that is solved problems, so don't worry, we will solve that. Okay, and now same cases I have defined for strong bases and weak bases as well. So same thing, strong bases kya hoga, which undergoes maximum dissociation, right? So same, the chemical species which ionizes completely, right? I have given all the bases, strong bases list. And then weak bases kya hoga? Yes, which undergoes partial dissociation. Same explanation like I have taken in the case of acids. अभी ये क्या है partial dissociation? अभी देखो ये जो bases है weak है तो obviously we will have undissociated molecule also. For acid we have defined Ka. Similarly, we have to define Kb for bases, which is a base dissociation constant. Same thing, sir, dilution करने से इधर number of OH minus क्या होगा? Please you try to think about that. Similarly, since we have taken weak base, it will undergo partial dissociation, right? Partial dissociation में involve होगा. And now partial dissociate हुआ, and then upon dilution, so obviously the number of OH minus ions are going to increase in the solution. Number of OH minus increase हो रहे हैं तो obviously Kb भी increase होगा, because OH minus concentration is directly proportional to Kb, and then alpha value anyway it is going to increase. So finally what we can conclude, that is, yes, please try to see here, that is, yes, sir, upon dilution alpha increase होगा, number of H plus ions, sorry, OH minus ions increase होगा, basic strength increase होगा, और Kb भी increase होगा, very important. Similarly, this box is also very important. Likewise, I have discussed in the acids. Sir, acidic strength Ka को directly proportional, so here basic strength Kb को directly proportional and inversely proportional to pKb, which is again minus log of Kb. You will see in the next videos. Okay, right. And then similarly, when we have two different bases and then their corresponding alpha 1 and alpha 2, Kb1 and Kb2, suppose, let's say. Okay, and then next relative strength, similarly we can write down that alpha 1 by alpha 2 is equals to, that is, Kb1 by Kb2, right? And now let us just talk about the merits and demerits of this Arrhenius theory. Okay, by considering Arrhenius acid base theory we can clearly understand, simple to understand acids and bases, right? And then given a clear idea about neutralization, yes, acid plus base gives salt plus water, beautiful. And then explained about relative strengths of acids and bases, that is one of the very beautiful outcome we can expect from this, what is that, Arrhenius acid base theory. And now we have some demerits also. It doesn't mean that it is the ultimate final successful theory. So it is just applicable for aqueous solutions. Yes, we have discussed, according to Arrhenius, acid is something which gives H plus ion in water, base is something which gives OH minus in water. So aqueous solution के बारे में ही बताया. So he didn't explain about non-aqueous solution. So that is, yes, failed to explain acidic and basic properties in non-aqueous solutions, right? Beautiful. And now according to Arrhenius, we know that acid is the one which gives H plus ions in water, base is the one which gives OH minus in water, right? And now अगर मेरे पास SO2 है और CO2 है और SO3 है, and then likewise we have some non-metal oxides. So these are all non-metal oxides, right? So generally from the periodic classification we can understand that non-metal oxides are generally acidic in nature, and then metal oxides are basic in nature. Chalo, let me take some more examples here. That is Na2O metal oxide है, CaO metal oxide है, and then MgO metal oxide है. And now अगर ये metal oxide है तो basic nature show करेगा. And according to Arrhenius, the base is the one which gives OH minus ion. But इस compounds में OH minus ions लाने के लिए OH groups ही नहीं है. These compounds don't have a hydrogen at all to give us H plus ions, but still they are acidic. Everyone started asking him, questioning him. So that is the one of the failure of this particular theory. That is, failed to explain acidic natures of non-metal oxides like SO2, SO2, SO3, and then so on. Okay, which do not have hydrogens to give H plus ions. How can they called as acids, but even though they don't have H plus ion hydrogens to give us H plus ions? So he just becomes silent. And the next, the same thing, failed to explain basic nature of metal oxides which do not have OH minus ions to produce. Yes. Okay, and then failed to explain basic nature of ammonia since it doesn't have OH minus. Yes, ammonia bhi base hai. We know that, right? Ammonia is a base not because of OH group. इसमें तो OH group नहीं है. Now later theories have told that NH3 is a base because it is electron pair donor. Yes, आने वाले theories में हम देखेंगे. Very important beta. Okay, right. And now it failed to explain the basic nature of NH3 since it doesn't have any OH minus ions groups to produce OH minus ions. Right, right. And then failed to explain acidic nature of electron deficient species like AlCl3. Yes, AlCl3, BF3, all these are acids. Generally they behave as they show acidic nature, and then he failed to explain that one also. Okay, so the later theories will explain about all these things. Okay, let us just wait for that. And now in this particular video what I am going to do is I am going to involve this particular few questions. The problem zone I have taken, which of the following is the strongest acid? Ka values diya. So they have given Ka values and they are asking about the strongest acid. Ka must be more, right? Acidic nature is directly proportional to Ka, right? Okay, beautiful. And now what we need to understand, okay, right, so acidic nature will be more for the one with more Ka. So देखो एक बार Ka का value कहाँ ज़्यादा है? So 2 into 10 power minus 1, 2 into 10 power minus 2, minus 3, minus 4. Obviously the first one will have more Ka, that will be the strongest acid. And then second one is also strongest acid. Now pKa values have given. pKa is inversely proportional, right? Lesser the pKa, more the stronger the acid, right? Right. So that is pKa1, pKa2, pKa3, pKa4. Lesser the pKa, stronger the acid. Superb, superb, superb. And now which of the following will have alpha less than 1? Alpha less than 1 किसको हो सकता है? Weak acids or weak bases, right? So देखो इधर the options दिया हुआ, that is HCl, HClO4, H2SO4 and CH3COH, which is nothing but the alpha less than 1 for weak acids and weak bases. Yes, CH3COH is a weak acid. Okay, and then next is strong base. They are asking strong base by giving Kb values. Strong base Kb must be more, right? So that is 10 power minus 7, 10 power minus 2, 10 power minus 5, 10 power plus 2. Yes, that is the more. Kb more, basic nature more. And now calculate the relative strengths of formic acid and acetic acid having dissociation constants. So Ka1, Ka2 का values दिया, and now they are asking us to calculate the relative strengths of formic acid and the acetic acid, that is alpha values they are asking. Just you try to solve this and then you are going to get this particular option. Okay, yeah, with this I am going to end up my video. So in the next video you are going to see Bronsted-Lowry theory. Okay, so Bronsted-Lowry theory is also very important for competitive exams. Don't miss that video also. So before that you just you try to scan this barcode and then get the notes and then try to understand the things and then try to maintain the things in one particular place. That helps you in the final preparation of your competitive exams. Okay, hope you like my video. So please, I want your continuous support. Yes, I have been getting so many appreciations from the student side, actually students and parents side. Yes, within my particular surroundings, within my particular contacts, they are just supporting like anything. Sir, just you please upload this particular chapter video and this particular chapter video bolke. So they are supporting continuously. So thank you so much for all your support. And then yes, I'm assuring you, I'm promising you, I will be going to upload so many difficult and different videos in an easier way. Yes, okay, scan this and then try to get the notes. So right, see you in the next video with the Bronsted-Lowry theory. Until that, signing off. Thank you.